Hello, Soch 530 students. It is March 30th, or this is the March 30th content. And again, I'll be presenting in a series of videos that I'll post on Western Online, and then I will also post the lecture slides in PowerPoint for you to go back and look at as well. Today we are going to begin covering Chapter 10 in the Krieg text. We're only going to cover a portion of the chapter. What I want to focus on this week is just the section on correlation, so the first about half of the chapter. Next week, I'm going to continue with Chapter 10 and finish up by talking about linear or bivariate regression, and then use that as a way to transition to talking about multiple regression for the remainder of the class meetings that we have. Because I now know that we can all get access to SPSS, I am going to also start in the next week posting additional SPSS assignments as well as homework so that we can be practicing using SPSS to run those same calculations that we've been learning how to do by hand over the last couple of class meetings. So start to look for that. If you haven't installed SPSS on your computer or your laptop, please go ahead and do so. I know that you're able to access it, and you should have gotten an email from UTech or from Joe Butcher, who is from UTech, with instructions on where to go to get the software and how to download it and install it on your computer. If you have any questions about that, feel free to get in touch with me. Since we started before break talking about chi-square, we've been talking about measures of association. And measures of association examine how two or more variables are related to one another and how that relationship or association can allow us to make predictions. We have been looking at contingency tables or cross tabulations. And in some cases, I illustrated to you how you could visually see that those two variables were related because the frequencies seem to aggregate in certain cells. And so you would see this pattern where the variables would come together and the largest frequencies would be in opposing columns and rows, which kind of showed you that that notion of predictability, so that I can predict knowing this because of even visually kind of see that because of how those variables come together. So in the last chapters, we've been looking at chi-square and other measures of association, first for nominal and then for ordinal level variables. And last week, we covered 6 different measures of association and PRE measures for nominal and ordinal level measures. This chapter introduces correlation and another measure of association and regression, which is does something really powerful. And you'll see most of the research that is published and some of the articles that maybe you're looking at for thesis work or for graduate work are going to be using regression because it allows us to assess the impact of one variable on another. So we'll be able to get a sense of how important this variable is, not just whether it's the relationship is statistically significant, but also how important is that variable? So how much influence does it have in a measurable way? But we'll start talking about that next week. Correlation allows us to assess relationships and associations for interval ratio level variables. So we've been dealing with nominal variables with chi-square and phi, and the ones that we talked about last week, and then ordinal level variables with gamma and Summers D, which we also introduced last week. We now have a statistic with correlation that allows us to do that in dealing with interval ratio level variables. And we can look visually in the same way that we looked with our cross tabulations. Before we even do any calculations, we can kind of get a visual sense of what that relationship looks like or how big that relationship is by creating a scatter plot of the data. Scatter plots are created by plotting on a graph the intersection of scores for two variables. So let's say, for example, and this may be a little bit fuzzy on your end, this is a scatter plot of responses to questions, the number of hours spent watching TV per day, so right here. Oops, sorry. and the how often the person visited their public library in the last year. So, what kind of pattern do you see? One of the things that we see is that, so this is the number of visits. Need that to go away. Okay, I can't figure out how to do that. Sorry, guys. I'll just do my best not to scroll down towards the bottom. So we have along the bottom, we have the number of hours spent watching TV per day. And along this axis, we have how many times somebody visited the public library in the last year. So what we see is that the more times the people who visited the library the most, they tended not to watch less TV per day. So they were spending, all of the people who had 50 or more visits to the library last year watched less than 5 hours of TV a day. And then if you go down to this section of the curve, the people who were least likely to visit the library, so those who didn't visit it at all in the past year, they watched the most television. So we kind of see a little bit of a trending line coming down this way. So we kind of see something happening where you have the data clustered. Now, you certainly have a lot of people in this lower section that don't watch much TV, but may also not go to the library very often. But I think we can probably see that there's a pattern here. There's a trend line that we can point to. Here's another example. This is one of those classic examples of ice cream sales and temperature. And we talked about this example previously. Ice cream sales and temperature. So this is temperature given to us in Celsius, and these are data points. So essentially we collected data on, in a given month, what was the average temperature in that month and how much was spent in that community or that city on ice cream during that month. And so we have each of our data points for the same periods of time. So during a month when the average temperature was 14.2 Celsius, the average ice cream sales were $215. If we continue to go down, we can see that there seems to be a pattern. Like this is 16.4, that's higher. This is 11.9, that was a lower ice cream sales. Here we have 25.1, which is actually quite warm in Celsius if you want to do that calculation between Fahrenheit and Celsius, and an expenditure of $614 that month on ice cream sales. So we also so if we plot these, so this one right here is that 11.9, this number right here, and then the $185. So this is 11.9 and $185. So that's a data point. So each one of these dots represents a data point from the chart on the left. And you can kind of see the line, right? The data kind of goes up. The warmer the temperature, the more is spent on ice cream during that time period. Correlation is often misinterpreted because we know that correlation is not causation. We talked about this earlier in the semester when we looked at spurious relationships. And just because two variables are related to one another, knowing one helps us to predict the other. So knowing that it's hot outside in a particular month would lead us to predict that there was more ice cream sales in that month. Just being able to do that doesn't tell us that those two things are causally related. They might be causally related, and it probably is a causal relation. People eat more ice cream in the summer. It's warmer in the summer. And those things may be causally related. But just because they're correlated, because knowing one helps us to do a better job predicting the other, just because they're associated, when one happens, the other one tends to happen, doesn't mean that one is causing the other to happen. Many things are correlated with each other, but these correlations often don't make sense or tell a complete story. They're spurious correlations. Remember the one that I talked about earlier in the semester about the number of movies Nicolas Cage appears in a given year is strongly correlated or strongly associated with the number of people who drown in swimming pools. Now, clearly, people are not killing themselves in their swimming pools to get away from Nicolas Cage movies. That doesn't make any sense at all. Those things are correlated, but they are not causally related at all. So we talked about causal validity earlier in the semester, and this is probably the most frequently repeated statement about correlation. Correlation is not causation. Correlation is not causation, which is why we it's not a good idea to tie teacher pay to student outcomes, learning outcomes, because how much a student learns is based on so many factors other than how well the teacher does teaching. So we need to be careful not to make a causal claim just because two variables are correlated with one another. So we talked about the ice cream sales before with temperature, but there's also a very strong correlation between ice cream and crime rates. The As ice cream sales rise, so does the crime rate. And this does not mean, however, that ice cream causes people to be violent. It's the brain freeze, it makes them angry, they go out and engage in criminal behavior. Of course, that doesn't make any sense. The correlation is spurious. And in this case, there's an intervening variable that's missing, one that explains both, and that's temperature. So as temperature rises, people buy more ice cream. As temperature rises, the crime rate increases. And why does the crime rate increase? It has to do with more human interaction, people outside. And so they're more likely to get in fights. They're more likely to be robbed because they're out and about in the public and they're interacting with more people. But if we misinterpret this correlation and say that ice cream consumption makes people commit more crimes, this, of course, would be incorrect.